Chapter 15 is a continuation of the topic of probability. And in this chapter, we're going to be looking at some more complicated probability problems, including conditional probability, expected value, and how we use those to form some strategy in sports. And our first lesson, lesson 15.1, is on two-way tables and the addition rule. You used the addition rule back in chapter 14, but in this section, we're going to look at some different ways that we can apply this addition rule. So you probably remember that a two-way table displays the distribution of a categorical variable in two different contexts or summarizes the relationship between two categorical variables. In this first example, we're going to look at people's ability to do the taco tongue or evil eyebrow. Some people believe that the ability to do these is something that you're born with. We want to know if this is true and if these two abilities are somehow related. Now, in case you've not heard of these before, taco tongue means that you can roll your tongue up like a taco. So you can go ahead and try that at home and see if you're able to do that. The evil eyebrow is just raising one eyebrow at a time. And that generally seems to be more difficult for people than doing the taco tongue. Anyway, we're going to suppose that we have a class with 21 students. And so students would put tally marks on the board to indicate each of their abilities. For example, if you are able to do both of those, taco tongue and evil eyebrow, you would put a tally mark in this upper left box in the table. If you can do the taco tongue, but you can't do the evil eyebrow, you would put a tally mark in this upper right box. So each of those boxes represents a different combination of those abilities. So let's suppose for our imaginary class, this is what the results looked like. So we have 6 that can do both, 11 that can do the taco tongue, but not the evil eyebrow, 3 that can do the evil eyebrow, but not the taco tongue, and only 1 student that can do neither. Just like we've done in the past with two-way tables, we can do the row and the column totals, and therefore we have a total of 21 students altogether. Now we're going to use that two-way table to answer some probability questions. First one is the probability of a student that can do taco tongue. So probability of yes, taco tongue. We had a total of 17 students in the class that said they could do taco tongue. There were 4 students in the class that could not do the taco tongue. We had 9 students that could do the evil eyebrow and 12 students that could not. So notice in this case, we're using the row or the column totals out of the total number of students in the class. Now the bottom 4 probabilities in this section, we're looking at one specific box. So yes, taco tongue and yes, evil eyebrow is one box in that table. That's the 6 out of 21. Yes, taco tongue and no evil eyebrow is the 11 out of 21. And those two together make that row of 17 out of 21. No taco tongue and yes, evil eyebrow, 3 out of 21. And notice the 6 out of 21 and 3 out of 21 make that first column of 9 out of 21. And then finally, we have 1 out of 21 for no taco tongue and no evil eyebrow. So all of these are out of the class total of 21. Now we're going to combine probabilities using OR. And we know in the past that we've combined and found OR probabilities using addition. So let's see if we can do that here. The probability that a student is yes, evil eyebrow, we already know is 9 out of 21. The probability that they're no evil eyebrow is 12 out of 21. The probability that a student is yes, evil eyebrow or no evil eyebrow would be the entire class, 21 out of 21. Everybody in the class either can do the evil eyebrow or they can't. And we can get that by adding 9 out of 21 plus 12 out of 21. So just like we did in chapter 14, we can find the probability of 2 events combined with OR by adding the individual probabilities together. This was the addition rule that we used back in chapter 14. Now let's look at this example. Yes, taco tongue, probability of that is 17 out of 21. Yes, evil eyebrow is 9 out of 21. So if we want to find the probability of yes, taco tongue or yes, evil eyebrow, we're going to try to use addition like we did on the last question. So yes, taco tongue would be 17 out of 21, plus yes, evil eyebrow would be 9 out of 21. Now the problem with this is that when we add those together, we get 26 out of 21. And we know we can't have probabilities that are greater than 1, which means our top number, the numerator, can't be bigger than the denominator. Now, the reason that this is happening is because we have a group of students that we are counting twice. And for example, when we got that 17 out of 21, that was this entire first row in our table. The 9 out of 21 was this entire first column in the table. And when we added those numbers together, we have this group of 6 people that were being counted in the first row, and they were being counted in that first column. So we were double counting those people. So what we need to do to correct for that is we have to subtract 6 out of 21 so that we're only counting that group of 6 one time. And when we do that, that gives us an answer of 20 out of 21, which is okay because that's less than 100%. Now, what makes question 3 and question 4 different is the fact that in number 3, there is no overlap between groups. Yes, evil eyebrow and no evil eyebrow were 2 totally separate groups. But in number 4, we had an overlap. So we ended up with students that are counted twice. And those are the ones that were yes, taco tongue, and yes, evil eyebrow. So this illustrates a need for a different version of the addition rule. And the old version of the addition rule that we used in chapter 14 only worked when we had mutually exclusive events, meaning there was no overlap. Here we have a general addition rule which works for all events. And we're going to write that like this. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And this A and B is where those events overlap. Now, the tricky part is that sometimes you are not really told if they overlap or not, so you just always have to sort of be looking for that when you're doing these probability calculations. All right, here's example number 2. When a basketball player takes a shot, there are 2 possible outcomes. He or she either makes the shot or they miss it. It's also possible that the shooter will be fouled while taking the shot. So we're going to look at a basketball player named Chris who kept track of his last 50 shots and recorded the outcomes of each shot and whether or not he was fouled. Question A is asking, what is the probability Chris is fouled? Well, if we look at that top row of the chart, we can see that there were a total of 13 shots out of the 50 where he was fouled, so that would be 13 out of 50. The probability that Chris makes the shot would be everything in this first column here, and he made a total of 19 shots altogether, so 19 out of 50. Part C asks, what is the probability he was fouled and makes the shot? That outcome happened only on 3 of the shots that he attempted, and that would be the ones that are in this upper right-hand box. So that would be 3 out of 50. Now for D, we're calculating the probability that he was fouled or he makes the shot. So here we're going to add the probability that he's fouled, which is 13 out of 50, plus the probability he makes the shot, which is 19 out of 50. And notice you can see with those shaded rows and columns that there is an overlap. And that group of 3 that are in that overlapping region are being counted twice. So that's the part that we need to subtract. 13 plus 19 minus 3 leaves us with 29 out of 50. All right, why don't you pause the video and try example number 3 and see how well you understand this lesson. All right, we're going to start by filling in the row and the column totals. So we know the total number of wins and losses for the Lions and the number of games they played at home and on the road. The probability that the Lions get a win would be 9 out of 16. The probability that they have a home game is 8 out of 16. The probability they win and are playing at home is 4 out of 16. The probability they win or are at home would be the probability they win plus the probability they're at home minus the overlap, which would give us a total of 13 out of 16. The probability that the Lions get a loss would be 7 out of 16. The probability that the Lions get a win and a loss, well, this one would be 0 out of 16. It's impossible for that to happen. The Lions can't get a win and a loss in the same game. Now, the probability that they have a win and a loss is 0, again, because a win and a loss cannot both happen in the same game. And oftentimes we have events where both things cannot happen at the same time. And like I mentioned earlier in the video, that's what we know is called events that are mutually exclusive. Okay? In other words, there is no overlap between the events. So we'll define that now in your notes. If 2 events cannot both happen at the same time, or if the outcomes in each event do not overlap, we say that the events are mutually exclusive. And if 2 events, A and B, are mutually exclusive, then the probability of A and B, in other words, that they both occur at the same time, is equal to 0. So if we go back and look at the example from the beginning with taco tongue and evil eyebrow, the first question is asking, are the events yes, evil eyebrow, and no, evil eyebrow mutually exclusive? If you say yes, they are mutually exclusive, that means there is no overlap. And that would be the case for this one. No one in our class is both yes, evil eyebrow, and no, evil eyebrow. You either have to be one or the other. There's no overlap between those two groups of people. So because there's no overlap, we say that they are mutually exclusive. Now, if we look at yes, evil eyebrow, and yes, taco tongue, those do overlap, which means they are not mutually exclusive because we had 6 students in the class that could do both. That was the overlapping region, and that makes them not mutually exclusive. Please do the 15-1 assignment in your homework packet.